Congratulations, students! You've actually finished all the content we're covering this year in statistics. So it's time for a little bit of review. What you have here is a pie chart, also called a circle graph. And a pie chart is appropriate when you have either categorical or numerical data. The one stipulation is that each of the categories have to add up to 100% total. So in this diagram, it asks, what percentage of time did Katie spend on her physics homework? It doesn't say. Oh, so what we have to do is say, well, if they all add to 100, add what we have. 34 plus 16 is 50%, plus 12 is 62%, plus 11 for biology would be 62, 73%, plus 13 would be 86%. Subtract that from 100, it must be 16% for physics. So I can put that in here, 16%. Now, if Katie spent 150 minutes on homework, how many minutes were spent on Spanish? Well, she spent 34% of her time doing Spanish, so we can call that 0.34. That's 34%, because it's 34 hundredths, or per hundred, per percent. If we multiply that by the 150 minutes that she spent studying, we should get it. 34 times 150, 51 minutes. So she spent almost an hour doing Spanish. What topic took longer, writing or biology? Well, she was writing for 13% of the time. She was doing biology for 13%. So it looks like she spent more time doing writing. So I'm just going to highlight that one. Writing or biology would be writing. Katie thinks she spent as much time on Spanish as she did on art, writing, and biology combined. Is she right? Wow, that would be a lot of time for those subjects. Let me get rid of the highlighter. Okay, so art, writing, biology, 12 plus 11 plus 13 would be 10, 20, 35, 38%. Is that right? 23, 36%. Well, she only spent 34% on Spanish, so no, she's wrong. She spent more time than on Spanish. Maybe it just seemed longer. Which two topics combined require the greatest amount of time? Well, the one that takes the most time is Spanish, so we're going to have to try to put something with that. So we've got history is 16, that's more than art, biology, writing, or well, physics is what? Physics is also 16. So we can either, no, physics couldn't have been 16. Let's go back and do that over. But Spanish and history together made up 50%. So that looks like our top one. So Spanish and history. Spanish and history. Let me go back and check this one because I don't think I did it right. What percentage of time did Katie spend on physics? 34, 50, 62, 73, 86. Oh, only 14%. You should have caught me on that one. Maybe you did. Okay. So Spanish and history, definitely. Now, if Katie spends the next hour on her math homework, I was wondering why she hadn't spent any time on math. Notice that she spent time on art, but nothing on math. Well, if she spent the next hour on math homework, what percentage of her total studying will have been spent on math? Well, she spent 150 minutes already, plus another hour would be another 60 minutes. That's a total of 210 minutes. And she spent, now probability is always part divided by whole, so 60 for math divided by 210. 60 divided by 210. Ooh, some ugly decimal. So 0.2857. I'm assuming we can round this to the nearest hundredth or nearest tenth of a percent. So I'm going to call this 28. Oops, Let me get some space here. 28 point, that wouldn't be 5 because the 7 is 5 or more, so it rounds up, 0.6%. Well, that's good. She spent almost as high a percentage on math as Spanish. Of course, math is more fun. Katie has been tracking the amount of time spent studying. So is this variable qualitative or quantitative? Well, quantitative includes the word quantity, basically. So that's a numeric. And time is something numeric, so yes, it was a quantitative study. Is time continuous or discrete? Well, there are no gaps in time. It's got to be continuous. Discrete is when you have counting numbers like 1, 2, 3, 4, usually whole integers. Not always. Shoe size is one example we always use, where you can have size 9.5 shoes and 9 or 10. But I don't think I've ever seen a pair of 9.237 shoes. So that is discrete. It only goes up by halves. Number 8. Which scatter plot shows the strongest correlation? Well, it's certainly not the middle one. 5 is not much of a correlation at all. 4 is a strong negative correlation, I'd say, and 6 is a pretty strong correlation, but it's not as strong as the first one. So 4, which has a correlation, so that would be number 4. Which has correlation coefficient closest to 1? Well, number 4 is the strongest linear correlation, so you'd think it might be that one, except that's a negative correlation. So it would have to be closer to -1. So the one that goes up and is closest to a line would be number 6. Which would have a line of best fit with a negative slope? Well, again, that would have to be 4 because it has a negative correlation. It's going down as it moves to the right. Would the y-intercept for graph 4 be negative or positive? Well, if we were to continue that line, let's actually do that. I'm going to put a shape in here for it, and we'll get a line. If I were to put a line in here, it would match sort of like that. And clearly, this is hitting above 0 on the y-axis, so it's a positive one. So I like my little highlighter here. Let me get that back. Won't let me. Well, okay, well, we'll just make it bold. It would be a positive. Oh, there's my highlighter. Positive. Okay. Number 12. A random sample of people was asked to report and the age. Okay, so age got dropped out of here. The age and distance driven of their primary car. A line was fit to the data to model the, oh, they're over here, fit to the data to model the relationship. Which of these linear equations best fits the given model? So we're trying to identify the equation for this line. Well, if we look at this line, there are two things that we usually look at. The slope, which is positive, well, these all have positive slopes, and the y-intercept, which in this case is just above 0 here. So it's a positive, which means we aren't going to have the, we're going to have a positive 5 there. Can't be either of these last two. So C and D are just out of it. They can't be right. So let me mark those off. So I'm going to just cross those two off if I can. I can't. Oh well. So just ignore C and D. Those are gone. We know we have a positive 5 for our y-intercept. Okay, then the question is our slope 1x or 12x? And it looks like it's going up about 1 square for every square it goes over, but we have a different scale on the y and x axes. So here we're only going up by 1s, here we're going up by 20s. So if you only go over 1 to the right, then it goes up somewhere around 10, which means this 12x looks good. So the answer here would have to be B. Have to be this one here, 12x plus 5. So let's use that in this next part. Because here it wants us to evaluate it for the value 7. Based on this equation, estimate the kilometers in thousands driven on a car whose age is 7 years. So we're going to plug 7 in for our x. And if I multiply that out, 12 times 7 is 84 plus 5, which is 89. So that 89 is what we want here. Okay? The bus company wants to know if the number of complaints they received was a function of the number of buses it ran. The company carried out a study comparing the average number of buses per hour for different days and the number of complaints that it received on those days. The results are shown in the graph below. Which statement is the best description of the association between these variables? A. There tended to be more complaints on days with more buses. Well, the number of buses is on the x-axis, and as you move to the right, you don't have more complaints, you have fewer. So B, there tended to be fewer complaints on days with more buses. That seems to be the one. Now, which correlation coefficient R is most likely to match this graph? -1, negative 0.7, 0, 0.7, or 1.0? Well, we can't tell exactly what it is, but we do know it's a negative correlation. And it certainly is a correlation. It's fairly strong. It looks like they fall almost in a line. So we can get rid of 0, which would be no correlation. We get rid of the positive ones here. So I'm just going to block those out. They're in red. So we have either -1 or -0.7. Well, -1 would mean it's a perfect correlation, that they fall exactly on a line. And these certainly don't fall exactly on a line. So we're going to get rid of that. And all we're left with is, bingo, -0.7. So it's got to be that one. What is the control group in an experiment? A, the researcher, because he's in charge. Well, he's in control, but that's not what they mean. B, the whole group of subjects. No, those are just called the subjects, I think. C, the subjects who receive treatment. Well, that would seem to make sense because you're controlling them. You're giving them the treatment. But that's not actually what that is. That group is called the treatment group, or sometimes the experimental group. So D, the subjects who don't receive treatment, that's what a control group is. They don't receive the treatment. But if you look at E, the subjects that receive the standard treatment, that one's also right. So a control group either receives no treatment or they receive a treatment that is what they're used to getting anyway. So you're controlling for what they have had in the past. That's often done with trials involving medications, where they leave somebody on the standard medication and they compare them to a new medication. But the control group either has no treatment or they have the standard treatment. Now, when they have no treatment, remember that sometimes means they actually get a placebo, meaning a fake treatment. They call them a sugar pill, but I doubt that they're all that sweet or you'd notice. But the whole idea is they think they're being treated, so they may start to feel better anyway. Number 15, if two events are independent, the probability of A equals 0.56, probability of B is 0.25. What is the probability of A given B? That's what this A with a bar B means. The probability that A will occur given that B has occurred. Okay, well, if they're independent, that means that whatever happens to B is going to have no effect at all on A. So if the probability of A is 0.56, then the probability of this is also 0.56. Given the example above, what is the probability of A and B? Probability that both things happen. Well, when you're doing and, you're going to be multiplying the probabilities. In this case, they're independent, so you can just multiply them. You don't have to modify the second one. So we're going to have 0.56 times 0.25, and that would be 0.14 or 14%. Given the example above, what is the probability of A or B? Okay, so when it says or, that usually means you're going to be adding the